Thank you for tuning in. Also, a big thank you to AWS Game Mana team for organizing this great event. I'm very excited to be here, and today I'll be talking about how we are curating data to power deep learning at Nearmap. I am Suneeta Mall. I work as a principal machine learning engineer at Nearmap. There I lead a team called Data Engine who are responsible for engineering side of model data, model training, model deployment, and continual improvement over this. I have a PhD from University of Sydney and I have a 13 years of IT industry experience working on various domains such as data science, machine learning, big data, travel, GIS, telecommunication, and DevOps. I love building and creating things, and I also love learning and knowledge sharing. I do enjoy mentoring a lot. I actively speak at technical conferences, speaking over various topics such as Kubernetes, machine learning, data science. I author for O'Reilly, and I have also authored for IBM Redbook in past. I am mom to two little kids, 1 and 4, and in my free time I love baking sweet treats and cooking up a sweet storm. Let's talk about what Nearmap AI is. Nearmap is the provider of high-definition aerial imagery and location content. We have a petabyte of aerial and visual content, and we are every day capturing terabytes of more and more visual content. With Nearmap AI, we are looking to take this visual content and generate derived knowledge. This is achieved by generating a semantic knowledge web of where various things and stuff are in our livable world. These are various attributes defined as power lines, various types of vegetation, car, driveways, roof, solar panel, and many more. We already have about 30 plus attributes in production ready for use, and we are rapidly growing that list. With this semantic knowledge web, we generate what we call location intelligence. These are packaged data set that can easily be plugged into end users or customers' workflow to improve their solutions and products and optimize their workflow. One such example of this location intelligence is shown on the screen. Here we are talking about what is the building footprint, what kind of material was used in the roof like tile, shingle, what is the style or design of the roof like gable, and how much is a tree overhang if there is any. What underpins this sophisticated Nearmap AI product is a great technology called deep learning. Within deep learning, we are specifically talking about convolution neural network, which is a specialized class of supervised learning. Here, we take the image and the ground truth, and we feed these data to a mathematical model that learns itself the feature representation or a knowledge representation by looking at many of the data set. And once it has learned the representation, if we give it any image that it hasn't seen before, it is able to predict with certain confidence to what attributes a pixel may be. In a very simplistic term, a deep learning model is a compressed form of data that it has seen before. Now, deep learning is hungry for two things: accelerated computing and data. Today, we are going to be celebrating data, so we'll just talk about and focus on data. At Nearmap, we have various modalities of location content. We have images taken from various angles, top down, and various side angles like oblique, and various forms of 3D like mesh and point cloud. Our labelers are well-trained labeling staff who use our in-house built labeling system that leverages on various visual content we have, so they can visualize a certain location and object from many different angles to make a confident decision of what they are seeing in the image before they annotate for ground truth. And one such example is shown on the screen here. Deep learning is, as I was saying, hungry for data, and the importance of data is empirically shown in 2017 by the study I'm citing here. They have shown that As we keep growing the training data set size, the model starts to perform better and better, and the validation loss reduces sublinearly. What this is telling us is that the data size matter. The bigger the data is, the better the model will perform. However, data isn't a panacea. We cannot expect to throw infinite amount of data at a deep learning model and expect the model to continually perform better and better. At some point, we would be reduced to this irreducible error window, which would be really hard to close in. But what's more important to data size is quality. And it is very intuitive if you look at it. The model is learning the knowledge representation from the data it has seen. And if the data itself is not quite accurate, we would expect the model to be confused about things. And this is very well represented by this cartoon here. So at Nearmap, we take quality of our data very seriously, and we have come to evolve various practices and process. And I would like to give you a little sneak peek to what those are. The only thing that's true in our real world is imperfection. We as humans are not perfect. And also all models are wrong, only some are useful. This is a very interesting situation. We want our data to be perfect, but the sources that we have to build this perfect data set are imperfect. It needs a lot of curation and careful orchestration to make sure that the quality is highest. So this is a very standard model training and deployment workflow that you would have seen. We have some kind of a data capture program, then we have a ETL like pipeline that transforms that data set to make it training ready. Then we have a model training program and model evaluation, and then to deployment where model is deployment and ready for end users use. As I mentioned earlier, we have come to evolve this model data workflow quite extensively and have various additional branches and workflows, and I will talk more on these now. One such derivation is the correction workflow where our labeler, once they complete the job, some of the jobs go through the reviewing workflow where another labeler reviews their job and corrects if need be. This is obviously a very expensive effort because it multiplies the labeling effort by twice or as many review as would be needed. In addition to that, we have a model monitoring program. This is to handle the case where our model, when it's out in the wild and doing inferences, it sees things that it's not quite clear about what it is seeing. We capture those data and pull that back in our data set. And we extend that data set by means of adaptive sampling. We create more labeling jobs on these locations where our models are not so certain and pull humans in the loop to annotate and present the ground truth for those locations. And we feed that back into model training program so our models continually gets better and better over the locations they have not been better before. We know that labeling is an extensive effort, specifically when we are annotating at a pixel level. To help improve the labeling experience, we have started to use models to pre-populate the labeling job to where the model thinks the ground truth should be. And then we allow labelers to correct model's mistake and provide the ground truth. This is a very good example of both model and human in the loop working hand in hand to, to help us create a very good ground truth. Now, in addition to all these workflow, we also use model in some capacity to advise on quality, and we use that to identify where the quality of our data is not so good, and we feed that back as a correction program for our labelers to correct them on. Now, this was a bird eye view to how our model data workflow program looks like, And I will lead you with various examples to give you a sense of why we have adopted these complexities and diversions to ensure the quality. Like we said, mistakes are real. We humans make mistakes. This is one such example where a labeler accidentally missed labeling this particular roof where they annotated all the other roofs correctly. Sometimes we see labeler make mistakes because um, the objects are really hard to spot. Maybe they are occluded, or it's because of lighting or object placement. It's not really easy to spot. Sometimes perception is also a reason for why labelers make mistake. This is one such example where that particular vehicle is really very hard to see and blended in the vegetation that's there. Also, sometimes we see very interesting edge cases that are really hard to visualize if we don't see a visual evidence. This is one such example where a family has installed a trampoline in their backyard in an empty pool. Now, if we don't see these examples, it would be really hard to fathom a trampoline being in a pool, but there we have it. We do see various such extreme edge cases that are really hard to explain without looking at a visual evidences. One such approach that we adopt to ensure quality is by many opinion. We take a job and give it to many labelers to annotate, and then we take the majority as the right source. This is in this example, a labeler was to annotate for driveway, and this particular labeler was confused, and he ended up annotating for entire drivable surface, including the parking spots. And when we gave this job to many other labelers, we were able to eliminate this error case and ended up having a high quality data set. I talked about using models in quality check. This is one such example. A job shown here was given to a labeler to annotate for natural soft and grass. This is the annotation that they gave. As you can see, they completely missed annotating grass, and natural soft shown in pink for annotation is not quite done correctly. As you can see, it's really hard class to draw. Uh, but that aside, there are inaccuracies in this particular label, and this was flagged by our model, which suggested that there is inaccuracies in what it thinks should be the the actual annotation to what the annotation is. In this particular example, we use loss to identify the anomalies. One such example of using again model in the loop for quality check is this where a labeler missed annotating water in the job. We use also model in a very interesting case where we want to eliminate inaccuracies in the labeling due to noise such as shadow occlusion by cloud or tree, or maybe due to lighting condition, or just happens to be the case during capture that the object is not clearly seen. To identify such errors, what we do is we use model to predict on various um, images taken at a different point in time on the same location and average out model's prediction and compare it against a labeler's output. Here, the labeler annotated two swimming pools, but in reality, this is not correct. There is another swimming pool in the middle that was identified by using model in the loop over many time slice analysis. So this is a bit of a demonstration to how we use model to identify quality. And talking about demonstration, here is an example of how we use both human and model in the loop to assist with improved labeling experience and the labeling quality. Here you're seeing that the labeler's labeling job was pre-annotated by the model, and then the labeler is correcting the model's prediction by um, removing the inaccuracies and generating the good source of truth. We did a survey with our labelers to understand what their experience is, and majority of them agreed that using model in labeling program helps them do a better quality labeling and also do it more efficiently. So quality matters, feedback matters, labelers experience matters, but what also matters is feedback. We as humans um, are unstoppable. Our definition of things and stuff continues to evolve, as it's shown by little image here. In 80s, this is how we first envisioned the car to be, to now in 2018, where our perception of car is much different to how it was first visualized. And this is a good demonstration by cartoon to talk about a complex topic that's known as concept drift or data drift. And to avoid falling into this trap, we make sure that we are continually sampling and updating our knowledge of attributes as we keep growing in time. So this was all about model training data, excuse me. There is obviously a lot goes on the data engine side. We have various other complex scenarios that we need to cater to: model monitoring, model management, understanding the relationship between various attributes and how we could leverage that to have a better models is another aspect of it. And then also we haven't even started talking about what goes on in model building, model training, and model deployability. I would like to talk a little bit more about our tech stack. We use AWS, that's in the center and the very heart of it. It is our primary cloud provider. On top of AWS, we run Kubernetes. We are actually a big Kubernetes fan. And then on the data side, we use Snowflake, Looker, S3, and also we use Kafka for eventing and messaging backbone. We use TensorFlow for our language SDK, and also use Golang, C++, and Python for language. As I said earlier, we very much are a heavy user of AWS. In fact, we are one of the biggest users of S3 in Pacific. And also we also one of the bigger user of AWS EC2 instance. We actually run thousands of EC2 instances to um, to generate our data, do our inferences, and also do our ETL pipelines or data pipelines. We have spoken heavily in past about how we leverage AWS in running inferences at scale, and specifically how we use AWS Spot instances to run at scale, push boundaries, but still keep our cost optimized. And I would like to point your attention to some of these articles here. And with that, I would like to take a minute of yours to talk about we growing our team. I'm hiring, looking for software and data enthusiasts. If what we talked about today seems of interest to you, you would like to find out more, please reach out to me. My email is mentioned there. I'm also available on LinkedIn. Also, if you're not looking for opportunities right now, but what we do, what we um, talked about today seems of interest to you, then please reach out to me. I would like to hear more from you, and maybe we can look about things in future. And also feedback, please do reach out to me if you have any feedbacks or you would like to exchange notes, learn from each other experiences. Would be very happy to have a chat and see how we can learn. And with that, I would like to close off and take questions if there are any. Thank you very much. I did enjoy talking about how we do AI at Nearmap. Thank you.